Hello, Algebra 2 folks, and welcome to Using Trigonometry with Right Triangles. You need a calculator, a pen or a pencil, and notes. So our target goal today is to extend our knowledge of trigonometric functions beyond the three basic ratios that we know, which is sine, cosine, and tangent. All right, so you need to write this down in your notes. This is a right triangle, and as you can see, the hypotenuse is labeled, and we know it's the hypotenuse because it's across from the right angle. This is called theta. It's just a way of distinguishing the angle. So this is where we are standing. Okay, anytime we have the angle that we need to be at, I always put a smiley face there so I know where I'm at. And then I know that across from where I'm at is the opposite side. And the side that I am closest to is the adjacent side. So what we know are these three basic functions. We know sine of theta would be opposite over hypotenuse. Okay, so. And then we know cosine is adjacent over hypotenuse. That's so, ca, C-A-H. And then we know tangent is opposite over adjacent, which is TOA. Okay, so we know the three basic functions, so, ca, TOA. Okay, now we are going to learn three other trig ratios, and those are called cosecant, and cosecant is abbreviated CSC, and really what that is it's the inverse of sine. Okay, so we know that sine is opposite over hypotenuse. Well, cosecant is hypotenuse divided by opposite. Okay, and then there's secant, which is the inverse of cosine, or 1 over cosine, or another way I could say that is the hypotenuse over adjacent. Secant is abbreviated SEC, okay? And then there's cotangent, which is the inverse of tangent, which is 1 over tangent, or instead of having opposite over adjacent, it would be adjacent over opposite. So these are the three new trig functions that we need to know: cosecant, secant, and cotangent. Okay, let's practice them. All right, I want you to evaluate the 6 trig functions of the angle theta. Okay, so I have a right triangle, and here's my theta. So this is where I will be standing. Okay. So I put a little smiley face at that angle. I know the 17 represents my hypotenuse. I know the 15 represents the opposite side, because that's opposite of where my angle is. And then this side right here would be my adjacent side, but I don't know that adjacent side. So in order for me to find that adjacent side, I would need to know the Pythagorean theorem. And that would be 15 squared plus the adjacent side, so a squared, equals the hypotenuse squared. So 225 plus a squared is equal to 289. Subtract 225 from both sides, and I get 64. A would equal 8. So this would be 8. Okay. So now that I know all three sides, I can set up my 6 trig ratios. So sine, let's go through that again, is opposite over hypotenuse. Opposite would be 15. Hypotenuse would be 17. Cosine is adjacent over hypotenuse. That would be 8 over 17. Tangent is O over A, which is opposite 15 over adjacent, which is 8. Cosecant is hypotenuse over opposite, which is 17 over 15. It's the inverse of sine. Secant is hypotenuse over adjacent, which is 17 over 8, which is the inverse of cosine. And cotangent is adjacent over opposite, which is 8 over 15, which is the inverse of tangent. So all these trig functions are ones you need to know. So you also need to know cosecant, secant, and cotangent. Okay, let's do another example. Let theta be an acute angle in a right triangle. What are the exact values? I want exact values. I don't want decimals of the other 5 trig ratios in the triangle. So we are going to make a triangle, a right triangle. Okay, and we are going to do an acute angle. So this is our acute angle. So this is where I'm standing. Okay, this would be adjacent. This would be opposite, and this would be my hypotenuse. Now, if I know cosine, I know A over H. So I know adjacent is 7, and the hypotenuse is 10. Okay, so I am going to put those in different colors here. I know this is 10, and I know this is 7. Okay, I need to find out what the opposite is, so I'm going to use Pythagorean theorem. 7 squared plus the opposite squared equals 10 squared. So 49 plus b squared equals 100. Subtract 49. I get b squared equals 51. b equals the square root of 51. So the opposite would be the square root of 51. So now that I have my 3 numbers, opposite, adjacent, and hypotenuse, I can find the other 5 trig functions. So we know sine is opposite over hypotenuse, which would mean that sine of theta would equal opposite, which is the square root of 51, over hypotenuse, which would be 10. Okay, there's 1. We would know tangent is opposite over adjacent. So the tangent of angle theta would be opposite, which would be the square root of 51, over 7. Okay. That's about 51. Sorry about that. Okay, so that's the next one we know. Okay, now we have to do the other 3. So we have to bring our resources back and try to remember what those new ones are. Well, first there's the cosecant, and cosecant is hypotenuse over opposite. So cosecant would be 10 over the square root of 51. Uh-oh, we can't have the square root of 51 on the bottom. That's not acceptable. So we got to multiply the top by the square root of 51 and the bottom by the square root of 51. And we get 10 square roots of 51 over 51. That would equal cosecant of theta. Okay, you got to rationalize the denominator. All right, then we know the next one is secant. Secant is hypotenuse over adjacent. So the hypotenuse is 10 over adjacent, which is 7. So secant of theta would be 10 over 7. That'd be the other one. And then the last one is the cotangent. And cotangent is adjacent over opposite. And that would be, cotangent would be adjacent, would be 7 over the square root of 51. We can't have the square root on the bottom, so we're going to multiply the top by the square root of 51 and the bottom by the square root of 51. So cotangent of theta would equal the 7 square roots of 51 over 51. So that would be the other 5 trig functions. All right, here's another example. In days to come, we are going to be spending a lot of time with 30, 60, 90 triangles and 45, 45, 90 triangles. So we need to practice finding different trig functions that are exact. So we want the exact values, which means no decimal answer. Okay, no decimals. Using 30, 60, 90, and 45, 45, 90 triangles. So we want the sine of 60. So remember the sine of 60. I have 2 triangles here. I have a 30, 60, 90 and a 45, 45, 90 triangle. Remember, short leg is 1, the hypotenuse is double, and then the long leg is 1 square roots of 3. And since I want the sine of 60, this is where I'm going to be standing. Okay, and remember sine is O over H. So the sine of 60 in this triangle would be opposite, because this would be the opposite, the 1 would be the adjacent, and the 2 would be the hypotenuse. So this would be the square root of 3 over 2. Okay? If I want the cotangent of 30, what I would do is I need to be at the angle 30, not at the angle 60. So I'm going to erase these values where I have the opposite, and I am going to go ahead and put myself at the 30. Okay, now this becomes the adjacent side, and this becomes the opposite side, and this would still be the hypotenuse. And now I want the cotangent. And remember, cotangent is the inverse of tangent, which would be A over O. So adjacent would be the square root of 3 over the opposite, which would be 1, which is the same thing as saying the square root of 3. Okay, now I want the secant of 45, so then I would need to use a 45, 45, 90 triangle. And remember, both legs are the same. Then the legs times the square root of 2 would be the hypotenuse. Now, since they're both 45, it doesn't matter where you put yourself. So if I put myself here and I want to do secant, remember secant is the inverse of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So hypotenuse would be the square root of 2 over the adjacent. This would be the adjacent, would be 1 over 1, which is the same thing as the square root of 2. Now these are 2 types of triangles that we are going to be using a lot in the days to come, like I said before. So please make sure that you know where you're at when I ask you about the angle, and that you can identify opposite, adjacent, hypotenuse, and you can give me the exact values without decimals. All right, well that's all I have for you today, and we will be practicing this in days to come.